Yep. So let's be sure that we're actually streaming first. Yep. Everything looks good. So hi everybody and welcome to the second this is the second time I'm doing this obviously. So the way this works is I'm going to try to do this algorithms thing for 31 days and see how better on the 31st day I'm going to be compared to the first day. And the way like this is going to work is I'll just randomly go on LeetCode, pick a medium difficulty algorithm and try to walk through it. Now all this is just to have myself accountable for learning algorithms, which is one of my goals in 2024. So let's head over to LeetCode and see if I'm still signed in. Okay, not signed in anymore. I'm just gonna put my phone and open. Great, so let's sign in. And I'm going to give myself 10 minutes or 15 minutes to try to figure out a possible solution, and then 10 minutes to code it if I eventually get a solution that's going to work. If I don't, I'm going to give myself extra. Sorry about that, guys. I'm going to give myself extra, maybe 10 or 15 minutes to kind of like go through the solution and see. So we'll go to problems and I'll try to pick difficulty medium. Or isn't this working? Yep, okay, difficulty medium. Status, I don't care if I've done this before already. And yep, so we just randomly pick one here. Great. Looks good. No, I don't want to dynamic layouts. I don't know yet. So this is the problem. And let me give myself a timer of 15 minutes to kind of understand this question. Yep. 15 minutes and let's go. So the name of the question is maximum side length of a square with sum less or equal to threshold. Given an m times n matrix max, which is like a multidimensional array, right? And an integer threshold, return the maximum side length of a square. Maximum side length of a square with a sum less or equal to the threshold, or return 0 if there is no such square. So right off the bat, I can classify this question into let's see, there's a tag for this. Yeah. Oh yeah, the prefix sum. That was what I was going to say. So the prefix sum is as I remember, it's an algorithm or a pattern which works by taking a sum and then storing it somewhere. I think it's been a while though, but let's see if we can actually propose a solution for this. So given an m times n matrix and an integer threshold, return the maximum side length of a square. So let's see an example. Imagine we're given 1, 2, 3, a 3-dimension like a 2-dimensional array, right? With 3 members. 1, 2, 3. 1, 2, 3. The output is 2 because the maximum side length of the square with sum less than 4, and then we're given 4. So don't get. Okay, so given this 1, 2, 3, the maximum side length. What is the maximum side length? Let's get the maybe not hint yet, but what is the maximum side length? I think the maximum side length. Maximum side length. I'm trying to. Okay. I think the maximum side length is. Let's get some hints to know what maximum side length is. I think the maximum side length is the length of the first rays, right? Okay, I wish I had more examples. I really wish I had more examples, but if the maximum side length is the sum of all items of the same index in the array, then the output here is 2. It was 1, 2, 1, 2, 1, 2. It seems like all the arrays are going to be exactly the same. That's what I'm noticing here. It seems like all the arrays are going to be the same. So if eventually all the arrays are going to be the same, so it's quite confusing to me what they are summing, to be honest. It's very, very confusing to me what they are trying to sum right now. But one way I understand this is we're going to be given arrays, the same arrays over and over again, because I can see here these are exactly the same arrays given here and exactly the same arrays given here. Of a square, okay. Maximum side length of a square with a sum less than or equal to. So okay, I see. So we have to find the maximum side length of a square. So a square means we are taking is this also a sliding window problem? No, it says binary search. So it seems like we also need some binary search here also. But I got to refresh on. I have to refresh on prefix sum and all that shit. But at least what we know from this algorithm is that what we know from this problem is that they are going to give us exactly the same amount of the same identical arrays x times, maybe 3, maybe 4, and we are to check the square. So if you plot this array on a 3D graph, on a 3D array, you want to have first, second, third, and then you can start from 0, 0. You can start from 0 and end the 1. Now, is the array going to be ascending? I don't know any of that. Also. So how would I solve this? I think the approach would be first to ask questions. Is this array sorted? Is it always going to be sorted, this array? And are they always going to be identical array? What? And then we can start at 0. Then we can start at 0. And since we are going to get a square, right? You can start at 0 and find every possible square in this array. So to find every possible square, we have to also know how to loop on the x-axis and on the y-axis, right? So I think what we have to do is take the sum of the squares of all squares. We have to take the sum of all squares first. And how are we going to store the sum of these squares? If this was an array, we would have another if this was a simple array, we would have another array of all the sum of all the prefix sum. But let's see some of the hints here. Just a second. The first hint is store prefix sum of all grades in another 2D array. It makes sense. Okay, so I'm to store prefix sum of all grades in another array. First of all, how do I know all grades? I'm to start at 0 here. 0 on the x and then 0 on the y. So we are going to loop both sides. So we're going to loop both sides starting from 0. So x is going to go from 0 to 1 to 2 to 3 to 4 to 5 to 5. So we're going to do 1, 2, 3, 4, 5, 6, 7. We're going to do -2. Yeah. I'm going to do I'm going to do length of all arrays. Just trying to think how this is going to work though. So you're going to do length of array -2 just to get one step backwards. And then the next thing we also need to do is the length of this array, right? And that is going to be length of parent array -2 also. So in this case, the first for loop is going to start from, is going to run 0, 1, 2, 3, 4, and 5. This is the first loop, right? And the second one is going to run okay, the outer one is actually going to run 1 and 2 because 3 minus because 3 minus 2 equals 1. Yeah. And this is going to run because 7 minus 2 is equal 5, right? Okay, sounds nice. Sounds like we're getting somewhere. So and then we are to store the sum of all grades in a 2-dimensional array. That means we are to store the sum of both grades in a 2-dimensional array like so. Why are we storing a 2-dimensional array and not in a 3? Oh, okay, because I don't know. But what this means is you are going to take the sum. We're going to take the sum of this plus this plus this plus this, right? But what I don't understand right now is of a square. I mean, if you sum this square, you're going to get 4. you sum this square, you're going to get 4. If you sum this square, you're going to get 4, right? So how are we coming about 2 here? Are we only summing like this or what? That's a good question. Like, if the answer is 2, how did you arrive at 2 here? How did you arrive at 2? That's a very good question. But then I have 2 minutes left. That means I wouldn't be able to solve this. If x is a valid answer, then any y. Not sure if I actually understand this question. This is where I'm stuck at right now. If the sum of square, if the side length, what does side length even mean of a square? When you say square, you mean 0, 1, 1, 1, right? So the sum of this is actually 4 and not 2. The sum of this is actually 4 and not 2. And then if it's 2, like what if it's 2, what, I don't know how to put it. If it's 2, then what like which side are we actually summing? Are we summing on the x-axis or on the y-axis? I think this is part of the questions I have. And I'm also out of time already because we have 33 seconds and I wasn't able to find a solution to this, but I just kept getting confused. But then a few facts that I understand is that the array is always going to be of the same length, the children arrays. And then it seems like they're always going to be identical arrays, like more like the same arrays over and over again, right? And yeah, I know it's a prefix sum question also, but then I think my time is up. So let's see the solution to this problem and how they think about it, at least. No, not the solution, the editorial. What do you mean you're working on it? What do they mean they are working on it? Okay, so if they're working on it, let's try to understand maximum side length of a square. Sorry about that's in discussion. I think this will be a hard problem, but it's definitely solvable once you realize the type of problem it is. You have to first calculate the sum of rows in advance. The sum of rows in advance. Compute sums by using the current value of your position on the grid minus the previous value, x minus 1. If you have 1, 2, 3, y equals 0, x equals 1. By doing this, you compute the sum of the square using the column values only. Okay, this is using the matrix, right? Okay. If you clearly remember you're looking for the largest square, so if you have a max of 3, wow, that's quite pretty hard to understand. Uh, and there's no editorial for this. Like that's bonkers. So I'm just going to look for the solution to this problem somewhere else. Most likely YouTube video stuff. And I think I can end this live out. And I'm also dying to know what the solution is, but I don't want this to linger for so long. I don't want this to linger for so long. Yep. So I'll just try to. Can I pause this live and come back while I know what the solution is? I guess I can. Can I pause this live?
Hey, what's up, guys? This is John here.
Chill a bit, bro.
And today,
Can you
let's take
chill
a
a
look at
bit?
1,200.
How to pause live stream OBS. You can't pause a stream. You can switch to a scene. Okay. So I'm going to switch to a scene. That's just going to be like me figuring out something. Of the audio here.